Hello students, today we are learning about symbol titration. Now the symbol titration that we are learning, we have this question. The one that we have learned in lesson 22 and lesson 23, they're totally different from this one. This one we are learning, this question is a little bit different from the one that we have learned, and the example says 15.3 gram of M2R 10 molecules of water contains 1000 milliliter of water, where we have another solution, molarity 0.099 molar of hydrochloric acid. We have the procedure: fill the burette with hydrochloric acid solution, pipette 25 centimeter of this compound, then you put in a clean conical flask, you add 2 drops of methyl orange, then you fill the table. So when you fill the table, then the first question is asking calculate the average volume of hydrochloric acid used. So average volume can be obtained. You take these values here, you have here, which is the volume of HCl used, 20.13 plus 20.13 plus 20.13. Then we divide by 3. Then we get it 60.13 divided by 3. Then we get 20.13 centimeter cubic. This is the mole. This is the number of moles of HCl. This is the volume of HCl used. This is the volume of HCl used. We have Roman 2. Roman 2 is asking the concentration in this compound in gram per liter. To calculate concentration in gram per liter of this compound, you use the formula. Here the formula, you have the mass, which is 15.3, and you have the total volume, which is 1000. Then this is what you see: 15.3 gram is equal to 1000 milliliter, and this 1000 we have it here. Then what about 1000? What about 1000 milliliter? This 1000 now I'm writing here is the 1000 for the concentration. Then you do cross multiplication: 15.3 gram times 1000 milliliter, then all over 1000 milliliter. Then 1 milliliter they cancel, 1000 they cancel. We will get 15.3 gram per liter. So 15.3 gram per liter. So this is now the concentration in gram per liter of that compound. Roman 3, it's asking the number of moles of hydrochloric acid used. To get the number of moles of HCl used, we have the molarity of HCl as 0.099. We have the volume of HCl used, 20.13. So this is what you do. Roman 3, 0.00, sorry for that, 0.099 moles, which is the molarity of the HCl. Here we have is equal to 1000. Molarity of any given value is in terms of volume is equal to 1000 centimeter cubic. What about the volume used, which is the average volume, the volume used, which is 20.13 centimeter cubic. So then is equal to, we don't know, x. So you cross multiply x with this one, then you all multiply this. 0.099 times 20.13 centimeter cubic. You are multiplying this one and this one, divided by 1000. Then this is what you get: 0.002 moles of which solution? Of hydrochloric acid used. So this is the number of moles of HCl used. That's how you do from Roman 1, Roman 2, Roman 3. So we have Roman 4 and Roman 5. Let us see it in the next page. The next page we have Roman 4. Given that 2 moles of the acid reacts 1 mole of the compound, find the number of moles of this compound. So they give us the mole ratio. Here we have the mole ratio in simple term. We have the mole ratio here. We have the mole ratio. Then the mole ratio here, Roman 4 is 2 mole ratio of the acid. 2 mole ratio of the acid is equal to the number of moles of the acid that we have obtained. The number of moles of the acid that we have obtained is 0.002. 2 in Roman 3. So 0.002 moles of the acid of HCl. So the mole ratio of the acid is equal to the number of moles of the acid used. What about 1 mole ratio of the compound? We don't know. X, then cross multiplication. Then 1 times 0.002 all over 2. Then the moles of the compound is 0.001 mole. So this is the number of moles of the compound. The number of moles of the compound used. The number of moles of the compound used. So that's how you do it. In Roman 4. Roman 5, this Roman 5, asking concentration of the compound in moles per liter, meaning that molarity. How do you get the molarity? Molarity, they're asking molarity. So how do you get the molarity? So to get the molarity, we use this. We have the number of moles of the compound, and we have the volume of the compound used. The volume of the compound used, this is we have in the equation. By bed 25 centimeter cubic of the compound and place in a clean conical flask. So the volume of the compound used is 25. Out of 1000 milliliter, we only use 25. So therefore, this is what we do. 25 centimeter cubic. This is question 5, Roman 5. This is Roman 5. 25 centimeter cubic is equal to the number of moles used, which is 0.001 mole. Why am I saying that? The reason is this is the volume, 25 is the volume used, and this is the number of moles used. They are equal. Then what about 1000? 1000 is always equal to molarity is in terms of volume is equal to 1000. Then you cross multiply. 25 centimeter cubic times 0.001 mole. Sorry, I'm making error here. Not that way. Cross multiplication is not that way. 25, we are multiplying first 1000 centimeter cubic multiplied by 0.001 mole over 25 centimeter cubic. Then centimeter cubic and centimeter cubic, they cancel each other. Then when we multiply this one, this one 1000 times 0.001 divided by 25, we will get the molarity of the acid is equal to 0.04 molar. Sorry, the molarity of the compound. The molarity of the compound is 0.04 molar. So that's how you do it in Roman 5. We have Roman 6. Roman 6 here is not enough. This page is not enough, but we can do it. Roman 6 is asking the value of M. The value of M, given that R is equal to 55, oxygen is equal to 16, hydrogen is equal to 1. So the value of M, they are asking this value of M. How do you get it? The value of M. How do you get it? To get the value of M, this is what we do. We have to get the RFM. To get the value of M first, we have to get the RFM. RFM, this is the formula that we can use. Molarity is equal to concentration in gram per liter over RFM. So we have to get first RFM. This RFM at the below. So molarity we have a 0.04. That's what we are getting right now. Is equal to concentration gram per liter we have obtained in the previous question. If I go back, concentration in gram per liter was in Roman 2. The concentration in gram per liter, and the answer was 15.3. So therefore, we will say 15.3 all over RFM. We don't know. Then is equal to, we don't know. Then it is equal to, we don't know. So this one is, there is one hidden here. So you cross multiply this one and this one. You cross multiply. So this is what we do. 0.04 of the molarity multiplied by the RFM is equal to 1 times 15.3. 1 times 15.3. So you divide both sides by 0.04. You divide by both sides 0.04. Therefore, RFM is equal to 383. When you get the RFM 383, then you take the whole compound, which is M2.R 10 molecules of water. Then you take the whole compound. That is, you will say it M2.R 10 molecules of water is equal to the total RFM that we have obtained, 383. So M, since it carries 2 and the value that we are looking is M, 2 will be the coefficient of M, which is 2M plus R. What do we have R? In the previous question, in the next question, in the previous question, R was 55. R was 55. Oxygen 16, hydrogen 1. Yes. R is 55. We have 1 R plus 10 open bracket. We multiply anything from 10 because 10, anything from water, we multiply 10. Hydrogen, we have 2 hydrogen times 1 hydrogen. 1 times 2 hydrogen because we have 1 hydrogen. Plus 16 oxygen is 1 oxygen 16 is equal to 383. What have I done here? The 2, the compound that the value that we are looking is 2 M, and it has a value which is 2. So the 2, you put it in front, you make it coefficient. Yes, 2M plus R, the value of R is 55. They give us in the bracket 10. Then 10, when I put here, I open bracket. Why am I open bracket? This 10 is multiplied across hydrogen and oxygen. So hydrogen, we have 2 hydrogen, 2 times 1 hydrogen. The reason I'm multiplying 1, we have 1 hydrogen in the bracket times 2 plus 16 oxygen because we have only 116 is equal to 383. Then here 2M therefore plus 55 plus, then in this 10 open bracket, 2 times 1 is 2 plus 16, 18 is equal to 383. Then here 2M therefore plus 15 plus 8, I mean 15 plus 10, 15 plus 10, I mean 55 plus 10, not 10, 55, still we'll rewrite it, 55 plus 10 times 18, 180, then is equal to 383. Then when you add here, you get it 2M therefore plus 15, 55, why am I saying 15? 55 plus 180, we get 235. 235 is equal to 383. Then you move this one, you transfer, you collect like times. 2M therefore is equal to 383 minus 235. Therefore 2M is equal to, you subtract 383 minus 235, 148. You'll get 148. You divide by both sides by 2, divide by 2. Then therefore M is equal to 148 divided by 2. You get 74. M is equal to 74. So that's how you calculate it. That's how you calculate it. Please subscribe and share my YouTube channel. I have a lot of questions related with simple titration. Almost 20 questions. I want to read almost 20 questions which are totally different. And these 20 questions is the past papers of KCC. Since we started learning KCC, doing KCC, please subscribe my channel. I am also going to start back titration soon. But before, I have to upload more videos about simple titration. If you have any question, please you can write in the comments so that I will further help you individually if you need a further help. Thank you.